Yes, so now, yeah, I hope it's
Yes,
visible now.
yes, sir. Yes, sir.
Okay, so let's start our today's class. This is lecture 14 on computer networks, and in the previous lecture, we were discussing IP header. Okay, and we have completed two fields of IP header, that was version and header length. Now we are going to talk about service type. So let me jump to the next slide and start this service type field. Service type, or you can say type of service. Okay, so first see this, how many bits, 8-bit field. Okay, so let's draw the 8 bits. 1 2 3 4 5 6 7. Okay, so these are the 8 bits. First 3 bits gives the priority to the datagram, and the next 4 bits are DTRC, and this bit is reserved for future. Okay, so you can say future, reserved. Okay, reserved for future use. Okay, so you can imagine it, DTRC, I remember it like DTC, Delhi Transport Corporation buses, DTC bus, so DTRC. Okay, and priority is say 000 to 111, like this. So 3 bits are there, na? So it can move from 000 to 111. Okay, and now they can say 1000. This means D means delay. So that means delay should be minimum, na? So D means minimum delay. Okay, so D means minimum delay. So follow that path which is having minimum delay. T means maximum throughput. Throughput should be maximum. So transfer the packet from where we have maximum throughput. R means reliability. So maximum reliability, and cost should be minimum. So minimum cost. Okay, so there are 4 types of services. That's why we are saying na service type. So which type of service you are expecting from IP? So if you say 1000, that means you want to send packet from minimum delay. Forget about cost, forget about reliability. You want that packet should reach as soon as possible. So you will fill this value as 1000. That means it will follow minimum delay path. Okay, and then 10100 maximum throughput path. Okay, maximum reliability 0010, and minimum cost 0001. You can mix them up also, minimum delay and maximum throughput 1100. Okay, and so on. So I think there is no doubt here.
Yeah, sir.
Okay, and what about priority? Priority means 000 means minimum priority, and 111 means maximum priority. That means if congestion occurred in the network, then which type of datagrams will be lost first, which is having 000. Okay, so 000 is minimum priority, and this is the maximum priority. Minimum priority, and this is the maximum priority. Okay, so in case of congestion, in case of congestion, 000 packet having or let me write it shortly. Okay, 000 packets will be lost first. Roughly I'm writing, will be lost first. Okay, that is the basic meaning. So packet having this field value as 000, that will be lost first. Okay, so this is type of service field. So if you have any doubt, you can ask me, otherwise I will jump to the next slide. Okay, so these are very simple things. Okay, let's see the next, total length field, that is 16-bit. Okay, total length. So total length field is of 16 bits. So what is the maximum number you can keep in 16 bits? 2 power 16 minus 1, that is all the 16 ones. What is the value? 65535. Okay, so 65535 is the, they will ask you directly maximum size of datagram. Maximum size of datagram, that is 65535 bytes. You should remember this. This is not bits, it is bytes. Okay, or they can ask like this also, 2 power 16 minus 1. And as the name suggests, total length means what? Header plus data. This is very important point. Header plus data. So if they say maximum size of datagram, you will say 65535. And if they say maximum data inside datagram, then what you will say? Maximum data in datagram. That means obviously what is the structure of datagram? Header and data. Okay, so header length minimum is 20 and it can go up to 60. I have told you na.
Yes, sir.
Minimum header length is 20 and maximum it can go to 60. So I want maximum data inside datagram. So obviously what I will take, minimum header, that is 20. So data will be what? 65535 minus 20. So you have to see carefully in GATE exam what they are asking. They are saying maximum size of datagram or maximum data inside datagram. Maximum data inside datagram can be 65515 bytes.
Yes, sir.
Okay, and they can say this also, maximum data or payload in datagram. Payload means data only. Okay, so this language is from transportation, like truck is having payload of 8 tons, like this we say in transport in the industry. So from there they have taken the word payload. Okay, so pay for the load, that is, okay, that's why this term payload. Okay, so I hope you have got the point. This is all about total length field. You can take the snapshot and then I will jump to the next slide. Done?
Yes, sir.
Okay, so what about the next field? Identification, flag and fragmentation offset. So we will study that in 3 fields. I'm skipping for now. Identification, flag and fragmentation offset. We will study this in another topic, that is fragmentation. And fragmentation is very important topic. Many times questions have been asked, directly or indirectly. Numericals also are coming in it. So we will study it, don't worry. But these 3 fields will be studied in fragmentation topic. It will be our next topic only. Okay. After IP datagram, we are going to start that topic only. Okay. So see the next fields. Time to lay field, TTL. So TTL field, let me tell you that. TTL field. TTL is time to live. Okay, so what this is saying, TTL field. So if value in this field is 5, that means your packet can you can say travel 5 routers and it can cross 4 routers. Okay, so let me tell you that thing first. Okay, what is this TTL and so on, and then I will tell you about what I was saying. Okay, so for example, this is this router has okay, so sender, first of all consider a sender. Okay, sender will set this field. Sender has set this field to be 5. So this router will first receive the packet. Obviously here is the receiver. So from sender, packet cannot fly away and go to receiver. It will be first received by this router. Okay, and then this router, what it will do? It will make 5 to 4 value. It will decrement by 1. Next router it will go. It will make 4 to 3. Next router it will make 3 to 2. Next router it will make 2 to 1. Okay, and if we have another router, there are many routers between. Okay, yeah, and if we have here is the receiver. If we have another router which will make 120, so the router which makes 120, it will simply drop the packet. This router will drop the packet and it will send ICMP message to sender that your packet has been dropped. So now this is the basic concept. Now I will try to show you that why this concept has been developed and so on. So first of all, please try to grab the concept. Concept is okay. What is TTL is doing? TTL field value 5. So this router will make 5 to 4. This router will make 4 to 3. This 3 to 2. This 2 to 1. And this router 1 to 0. The router which is doing 1 to 0, it will simply drop the packet. Okay, concept is okay. Yeah. Now I will tell you why this field
And
is
it
there.
responds back to the sender.
And it will send ICMP message to the sender. See, I have told you in ICMP when I was starting networking, I have told you, whenever packet is dropped, for whatever may be the reason, ICMP error message will be sent to the sender informing that your packet has been dropped.
Yes, sir.
Okay, so now there is a reason, particular reason. It has dropped the packet because it has made 1 to 0. So it will send ICMP error message to sender. Of course, format will be different, message will be different. Okay, so for each and every reason, there is an ICMP error message. Okay, so this is one of the reason of packet dropping, and it will send ICMP message to the sender that your packet has been dropped. Okay, yeah. So now basic concept is over, and they will ask in GATE exam. They will ask question like this. So you have to answer this question very carefully. What they are saying. So first question they will ask is TTL field value 5. TTL is equal to 5. How many router it will travel? how many router packet will travel. So I'm writing in a shortcut manner. I want to say that we have a IP datagram in header. TTL field is 5, and so on. I'm not writing that much. I'm just simply saying TTL field is 5. How many router packet will travel? So see this. You can count packet 5 now. 1, 2, 3, 4, 5th. It has traveled this now. It has touched it. So you will say 5. You will say 5. And another question they will ask is TTL field is 5. Let me copy it out. How many packet? How many router packet will cross?
4.
4. Yes, obviously. Okay. So generalize TTL field value n. Okay. So we can generalize TTL field is equal to n, means it can cross or travel. Cross n minus 1, travel n routers, n minus 1 routers and n routers. Any doubt here?
Nice, sir. Yes.
Okay, so that's all. So this is all about TTL and why this field has been developed. Let me answer that question also. You can take the snapshot. I will jump to the next slide.
Done, sir.
Now concept is over. Now question arises, why this field? Why TTL? Why time to live? See, sender has sent the packet to this router. Now router will send this packet to this, and then finally receiver will receive it. Now by how router will decide that it has received a packet, and now router will decide that where it should forward. There are many ports, output ports. There are many output ports. So now by chance if its routing table get corrupted, this is the routing table. Okay, and routing table is corrupted, and it has to transfer the packet to here, but it transferred the packet from this port. So now it will keep on rotating in the internet. It will not reach here because I am assuming that there is no path and so on. So you can imagine anything. So the basic thing is that if routing table is corrupted, then packet might you can say go to some other path. So it will keep on traveling other routers. So because routers might not know where this packet should go, other routers might not know. Okay, so that is the basic problem. So it will keep on rotating in the internet. Now if it has happened to one packet, it can happen to many packet and congestion will occur and entire internet will go down. Okay, and another reason is you can put any IP address like this, so hacking can be done easily, and you send a packet and it will revolve in entire internet like this. Okay, so adding ad agencies, advertisement will be done very easily, but the problem will be that internet will go down because of the congestion. Okay, now every ad agency will think of some other way to transfer the packet in entire internet. Okay, so no one can transfer packet in entire internet. That is very obvious thing. If someone can transfer packet in entire internet, then obviously ad agencies will do this kind of thing and an entire internet will be blown away. Okay, so routing table corrupted, and packet might go to some other path. Packet might go to,
I wrote it, sir, already.
okay, some other path. Okay, that's it. Okay, so this is the basic you can say TTL field. Okay, why we need TTL field? And another very good reason is they have asked this question, by the way. See this. So sender, and suppose here somewhere here it is, here we have a receiver. Now this router, because of routing table got corrupted, it transferred the packet here. This router transfer here, this router transfer here. So there is a loop, infinite loop. They will keep on sending packet here itself, keep on transferring here. Okay, so to prevent loop problem also TTL field is used. Another reason to prevent loop problem, TTL used. Okay, so obviously it will keep on decrementing. The router which is doing value 1 to 0, that will drop the packet. So simple. Okay. And this is the rule that whenever packet is 1 to 0, it will be dropped. Even no doubt it can be receiver also. if receiver has received the datagram, and it will also decrement the value, and if it has made 120, it will also drop the packet, it will also not accept it. Okay, so it is not the rule that only routers will do, receiver will also decrement it. Okay, let me jump to the next slide, take snapshot.
Done, sir.
Rule I am writing. Receiver will also decrement TTL field, and if it becomes 0, then receiver will discard the packet. Okay, so you should know this thing also, receiver will also decrement. It is not only router, receiver will also decrement it. Okay, so this is all about TTL. Next field, let us see what is the next
How will
field.
receiver receive the TTL, sir?
Please come again.
Then how will we make it reach to the receiver, sir?
No, we will put, we have to put big value, na. If you put here a TTL field to be 100 or say 50, then obviously it will receive, it will be reached by receiver. It will be received by receiver, na. Value should be big. Okay, and actually it is detail is not required, but I will tell you. So source will see, actually every router has routing table because they have to forward the packet. Similarly, source also has a routing table. From that table, it will come to know that within me and receiver, how many routers are there. So if routers are 10, so it will make TTL field to be 20. So double value it will take. Okay, for the safer side, it will take double value. So now after even doubling, it has not received. That means packet obviously has left the route. Okay, so now packet is off the beat, so it will be dropped by some router. That is the basic idea. Okay.
Yes, sir.
Okay, so that's it. So now let's see the next field. What about type detail protocol field? Okay, let me tell you about the protocol field. Protocol field means we have studied that in your Ethernet protocol also. So which higher layer protocol is using it? That's it. Okay. Which protocol is using IP datagram? Is using IP. That's it. Okay. Which protocol is using IP? So for example, for TCP IP, its value is 6. Just for, it is not required. I'm just telling you for just for the sake of example. If UDP is used 17, if ICMP is used 1, IGMP is used then 2. Just for the sake of your knowledge, I'm telling you that these values can be used. Okay. So protocol field is of 8 bits. So in 8 bits you will write the binary of it. 6. So 0 0 0 0 0 1 1 0. If this is the value, that means TCP IP is used. UDP means 17 and so on. Dot dot dot.
Yes, sir.
Okay, so this is all about protocol field. Next field, let us check that header checksum. Let me tell you that also. Header checksum. As the name suggests, header checksum means checksum is maintained only for header. I have told you IP has no error detection or correction scheme. So now why this header checksum has come into the picture? Okay, if you try to remember in checksum also I have told you this. Now when I was when we were studying error detection correction mechanisms. So IP has no error detection mechanism. Okay, or you can say IP has no error detection. Okay, there is no error detection. That means IP is unreliable. IP is unreliable. Okay, so now if it is unreliable, then how checksum? So because checksum is for header only and not for data. Checksum is for header only and not for data. Okay, it is only for the header. So now why this has been done? Because I have told you IP is best effort delivery system. Its main aim is to deliver the packet. That's it. So now who will find error in the data and so on? For that we have lower layer data link layer that will do it. Okay, and in fact upper layer TCP will also do it. So lower and upper layer will handle all these things. IP has no need to worry about the data is corrupted or not. Okay, and checksum is for header only. And let me tell you that thing also. See this, there we have a sender and there are multiple routers in between. So each and every router will calculate checksum again and again. Okay, and it is only for header. Why they are calculating again and again? Because there are many fields which are going to change, like TTL field. TTL field is always decremented, so obviously checksum will be disturbed now. So each and every router will have to calculate checksum again and again. Now imagine if data was also included, so it will be very tedious task for each and every router to do checksum again and again and again. That is very difficult. Okay, so and it is simply wastage of time also. That's why they think about, or networking people think that we should maintain checksum for header only and not for data, because they on each and every router, why you want to do all the things again and again? Because data, frankly speaking, data is not changing. In very worst scenario it will change, some noise or something might occur and so on, but it is not changing normally. Okay, but data inside header, or you can say header is changing now. Every time
Yes.
header is changed, TTL field is changed, and there are other fields also which will change. I will tell you, don't worry about them. So the basic thing is many fields are changing, so we have to calculate again and again. That's why it is for header and not for data. Okay,
Yes.
yeah, so you can write down checksum is for header only and not for data, because each and every router, because
Okay.
each and every router. Okay, you have written. Okay, then good.
Yes, sir.
Okay. Hmm. Yes, so now we will try to answer few questions. So rather, what about the other fields? Header checksum. So SIP DIP is very simple. We have told about IP addressing and all. So 32 bits SIP, 32-bit DIP. Options and padding, don't worry. I will tell you about these options also. So now our directly and directly our basic part of header is completed. Options, don't worry, we will tell you. Okay, and we have left these fields ID, flags, and fragmentation offset, that we will do in fragmentation. But now I want to tell you few questions, that how questions will be asked in gate from this header. First of all, first type of question is they will simply say version field how many bits directly, identification field how many bits, flags how many bits. Okay, and you have to remember this format also, because on this format also many questions have been asked. Let me tell you that also. Take this. Okay, so let me tell you few questions. Okay, you have taken this snapshot.
Yes, sir.
Okay. So they will say one question I have already told you, but let me repeat that also just for the sake of completion. First 8 bits of IP header is 01000010. Okay. First 8 bits of IP header is this. Router will accept or reject the packet. Router will accept or reject packet. Okay, so what should be our answer? So if you know the header, only then you will be able to answer it. Otherwise, you won't be able to answer it. But this is version 4 means, okay, we are talking about version 4. Next field was header length. Header length field is 0010. That means 2 multiplied by 4. Header length I have told you na, multiplied by 4. Header length is 8. How it is possible? It is not possible, because minimum header length field value should be 0101. So we will multiply it by 4 and you will get the answer as 20. Okay, so packet will be rejected like this. Any doubt?
I understood the 0010, that is 2 into 4, that is 8. And
Mm-hmm.
how did you consider 0101, sir? That should be.
No, I was just telling you that minimum header length field value should be this.
Uh-huh.
Minimum value. Minimum value should be this. Only then it will be accepted.
Yes, sir.
Okay, because it is 5 na. Decimal binary is 0101. So decimal is 5. So 5 into 4, that is 20. So 20 byte header is minimum in case of IP na.
Okay, sir. Yes, sir.
That's why.
I need the 60.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
So another type of question is they will say first 8 bits are 0100 1000. Now they will say how many options are there in header, how many bytes options in header. So you will say this is version, this is header length. Header length field is 8. 1000 means 8. So 8 into 4, that is 32. Now header is of 20 bytes, so 12 bytes. So how many bytes of options are there? 12
All right.
bytes. So simple. Okay.
Yes.
Take the snapshot. I will jump to the next slide.
Done, sir.
So now they will say, okay, let me make a question. So they will say first 32 bits they are giving you, first 32 bits. Okay, so 0 1 0 0, then they are saying about 0 1 0 1, then they are saying about, okay, and then they are saying is okay. Now in place of this also, see, 32 bits binary giving is very difficult task, so they can give you hex also, hex by 0x or 0 small x, like this. Okay, so they will say 0x 4 5 1 0 0 0 f f h means hexadecimal. Okay, so in place 0 capital X or 0 small x. So they are saying like this, first 32 bits of IP datagram is this. Now they are saying amount of data carried in header. Amount of data in header. Okay, so amount of data in header, how you will calculate? So see this, 4 means version is 4, version 4. 5, this 5 means header length field is 5, so 5 into 4, that is 20 byte header is there. Okay, and then these two we will simply ignore, because that is service type. See this,
Yes.
in header service type 8-bit na, and then we have 16-bit of total length. Okay, so these two we will ignore, it is not for our purpose. Now this is the total length field, that is 00ff. 00ff, this is hexadecimal, so binary will be, so directly calculate decimal. Decimal value will be 127. Oh, 255. 8 bits, 8 ones na, 255. Are you able to imagine or not?
I'm able to, sir, follow. I'll practice.
Okay, so okay, if you have an see, f means
I
1
can
1
do it.
1
No,
1.
sir, I know. Yes, yes.
Okay, so 255, and amount of data in header, amount of data, sorry, amount of data in datagram, amount of data in datagram, they are asking this. So what will be the value? 255 minus 20, this is the data na, because total length field means header plus data. Header is 20 and total length field is 255, so 255 minus 20, it comes out to be 235. So 235 byte of data is there in your datagram. Okay,
Yes, sir.
so they will say payload in datagram, so it will be 235. Okay, yeah, so that's it. So now take the snapshot. I will jump to the next slide.
Done, sir.
Another type of question is say 0x 450000080000100000102 dot 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 dot, like this, and they will say how many hop it will travel, how many hop this packet, this datagram will travel. Okay, yeah, so it will travel before being dropped, before being dropped. Okay, drop होने से पहले how many hop it will travel. So for this what we need? TTL field. So TTL field is at what point? You can check it out. TTL field is, see this, 4 byte 4 byte, 16 byte you have to miss, sorry, 8 bytes, 8 bytes you have to miss, and then after 8 byte you will get TTL field. 8 byte, 8 byte means 8 8 is 64 bits. Okay, 64 bits. 64 bits means divided by 4, 16. So 16 you have to miss. Are you getting it? 16 digits
Yes,
of
sir.
hex, because each hex digit means 4 bit. Okay, so 64 divided by 4, that is 16. So 16 you will miss 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So this two you will take. Why two digits? Because 8-bit field is TTL. 0 1 means only one. So I will say only one hop it will travel before being dropped.
So in the previous example, we saw 4 is for the first 4 bits.
Uh-huh.
So we count it as 1, 2, 3, 4 or 4, then 5, 9, उसके बाद 10, 11, 12.
I didn't understand your doubt. What you are saying? Please come again.
4 is the digit 4.
This one.
It was for the version 4 and it comprises all the 4 bits.
Yeah. So you version 0100.
So now when we are counting the 16 bits, we count this as 4 bits or 1 bit now. In the next question, sir.
So this hex is 4 bits now. 4 bits. 4 4 4 4. That's why I have told you 64 by 4 16 you will miss.
When you counted now all one after other, you counted 16, sir.
16, only 16. Why 16? Because each digit of hex is 4 bits. So 4, you can say like this: 4 bits, then next 4 bits. 8 bits are over, then next 4 bits. 12 bits are over. So if I say 1 2 3, so 3 means what? I have covered 12 bits. So multiply by 4. That's it.
So now you counted 64 bits or 16 bits, sir?
Here 16 digits of hex I have calculated. 16 digits of hex means 64 bits binary you have counted.
Yes, fine. I was thinking like 16 bits we counted.
No. We can. Oops. Data lost. I by chance I click this erase button and entire thing is gone. So what we have. What was the data? 0x450000280001. This was there, no? Dot. So we were saying 01. So I see this is hex. Each hex digit means 4 bits combination. Okay, because this 4 is 0100. This 5 is 0101. This 0 means 0000. This 0 means 0000 and so on. Okay, so if I skip 16 digits from here, then directly and indirectly I have skipped 64 bits.
Yes.
And I want to skip 64 bits only because TTL field will come after 64 bits. So this was the value. So one hop it will travel. Okay, before being dropped. Now from here you can get many things. For example, version is 4. You will say header length field is 5. Okay, so that means 5 into 4 20. So they can say size of header 20. Type of service, just leave it. After that we have 2 bytes of total length field. Total length is 28. 28 means 0010 and 0000100. So this is the total length field. So what do you think? What is the value of this? So it's very simple. I will say 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9 10. So 1 followed by 9 zeros. 2 power 9. That means 512. And then here I will add plus 8. So it is 520. So I will say 520 is the decimal value. 20 byte header is there. So data inside datagram. That is 520 minus 20. That is 500 bytes. Okay. So now you can answer many questions if you know the format. If you do not know the format, you will not be able to answer these questions. That is very obvious. Okay, because you do not know how many fields we should skip and so on. Okay, now so Any doubt here?
No.
Okay, so take the snapshot. I will jump to the next slide, and now we are going to start the very important topic, that is fragmentation. IP header is over now. Of course, options fields are left out, so I will tell you about options after completing this fragmentation part.
Done, sir.
Fragmentation. So before starting fragmentation, let me tell you a few basic points. There are two terms which are used interchangeably. Rather, they are different terms, but many teachers also speak these terms: fragmentation and segmentation. Actually, both are different. Okay, let me tell you that thing. Application layer has generated packet, or you can say data. Now this data is chopped into small parts, and that is done by transport layer. Okay, and we should say more precisely TCP. TCP has done chopping. I have told you, na, UDP and TCP basic difference was TCP can do chopping and all. Okay, so it will make small parts called segments. So this is known as segmentation. Okay, so TCP will do segmentation. So segmentation means application layer has given you stream of bits and you are dividing it into small parts or packets called segmentation. Okay, so after segmentation, IP will come into the picture. So we have got the segments. Now these segments will be packed in IP. Now IP datagram has been created. Okay, so IP has put its headers, and this is IP datagram. Now problem is that, see this. Now they will ask reverse question also. Okay, so maximum IP datagram size is 65535. I have told you. And minimum header is 20.
20.
We have already given this. So data inside IP datagram can be maximum of 65515. Now this 65515 is nothing but the segment size, total segment size. Are you getting it?
Yes, sir.
So now if I take header, and that is default also in TCP also same like IP. Okay, IP header minimum 20, maximum up to 60. TCP is also same. TCP header is minimum 20, maximum 60. Of course fields are different, but it can go to minimum 20 to maximum 60, and IP header also minimum 20 to maximum 60. So now 65515 is the total length of TCP segment. Any doubt here? And minimum header is 20. So this question have been asked in GATE many times. So maximum data inside segment, that will be 655395. Are you getting it? This is 65515. So 65515 minus 20 you will do, because header minimum is 20. So 20 plus 655395 is 65515. Okay, so no doubt
395 is 65515, sir.
655
395 minus 20.
plus 20 na header. Total is 65515.
Huh.
So header plus data is 65515 na.
Yes, sir.
So 655395. Acha, 495 you are saying. Sorry for that. Okay, 495. 655495. And
Yes,
plus
sir.
20 it will be 65515. Okay, now it's good. So now I want to say this thing. They will try to confuse you. They will say that there is a field in TCP. Okay, that is total length field. Actually total length field is not there in TCP. When I will tell you about header, I will tell you about that. But they will make hypothetical question just to confuse you. They will say that total length field is of 16 bits in TCP. Okay, maximum data in TCP that can be carried in internet, that can be carried across internet. So they will twist the question. So the moment you see, okay, total length field is 16 bits in TCP and minimum header we already know it is 20 bytes. So you will say 2 power 16 minus 1, all that means 65535, and header is 20. So you will say 65515, and many students will take this. But actually it is wrong. Why? Because it has to be, see, what I have used maximum data in TCP that can be carried across internet. So segment cannot fly away. Segment will be packed in IP datagram. So in IP datagram, maximum data can be 65515. So maximum it can be 65515 minus 20, that is 655495 will be the answer. It is not
So,
65515.
so it is 65495.
655 हाँ
65495.
हाँ 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 yes
आप बोल रहे हैं, मैं इतना
65495
फास्ट से लिखते थे हम।
पता है ना तो yeah so 65515 so 65495 should be the answer 65,495 okay yeah so total length is of 16 bits in TCP. Just to confuse you, total length is 16 bits in TCP. Maximum data in TCP that can be carried across internet. They have used the word carried across internet. So how a segment will be carried across internet? In IP only. Okay, so now IP, now think about IP. 65535 minus 20, that is 65515. So 65515 is the you can say maximum data that can be carried in IP datagram. So 65515 will be total length of your TCP. No doubt it supports 16 bit, but you cannot put 65535. You cannot make segment of 65535 bytes. Why? Because it has to be carried in internet across internet in IP. So I hope you have got the point. So what will be our answer? 65495. Okay. So any doubt here?
Nice.
Okay, so that's it. So maximum data is this. Okay, so now IP application layer message is divided into small parts. Okay, and each of size. Now you have to consider each of size 65495 bytes. This chopping is known as segmentation, and it is done at transport layer. Okay, application layer want to send huge message, so you will cut huge message into small parts, each of 65495 bytes. Roughly, I am telling you roughly. This process is known as segmentation. Okay, now after doing segmentation, now we have got IP datagram of 65535 bytes maximum. Now what if your network does not support 65535 packets? For example, you consider the below layer, that is your data link layer. In data link layer, what we have studied? Ethernet. So Ethernet, header, trailer, and data. So data inside Ethernet was 1500 bytes. Try to remember. I have told you minimum 64, maximum 1518. That was the total you can say size of frame. Minimum data was 46 and maximum was 1500. Try to remember. Okay, so 1500 bytes. So now obviously datagram cannot fly away. It has to be packed in data in your Ethernet frame. So how 65535 will come in 1500 bytes? That is not possible. So you have to do chopping of datagram also. Now this chopping process of datagram, that is known as fragmentation. And this is our topic in IP, that is fragmentation. Okay, so now fragmentation. So basic questions they will ask. First question, which layer will do segmentation? Transport layer will do segmentation. Which layer will do fragmentation? Fragmentation is done by network layer. It is not done by data link layer. It is done by network layer, because it's the duty of network layer to give proper size packet to data link layer. Data link layer will simply apply header and trailer, make the frame and send it onto the internet. Okay, yes, so take the snapshot. I will jump to the next slide and I will answer few questions now. Okay, so question number one. Which layer fragmentation? Answer, network layer. Question 2, which layer is doing segmentation? Which layer is doing segmentation? Answer, transport layer. Okay, yes. And why segmentation is done? So that application layer message can be chopped. Okay, application layer message chopped. application layer message chopped. Okay, and why fragmentation is done? Because datagram chopped. Datagram chopped. Okay, chopping of datagram, that is fragmentation. Okay, so now another beautiful point is coming in my mind. See, you might see, or you might think that fragmentation and segmentation both are necessary. We cannot avoid them. But see the beauty here. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, now see the beauty here. Application layer has generated the message. Transport layer will chop it, small chopping. Then network layer will again do chopping of the datagram. This is the datagram. So now if transport, see this. Now this is the sender. Okay, now sender is present in some network. Sender already know which protocol is used at data link layer, because it's the computer. It already know which you can say protocol is used there. So it already know what amount of data I can send in the frame. Now since sender they know this already, so why not transport layer do this thing? Why you are saying that transport layer should do chopping of 65495, and then your network layer will do again chopping? If this do chopping very beautifully, then we do not need fragmentation. Are you getting it? Okay, so that is the beauty here. So I want to say that segmentation is necessary, but fragmentation is not necessary at sender. Rather, sender will never do fragmentation, because it is the general rule that transport layer will make the packets in will do chopping in such a way that fragmentation is not needed at sender side, because sender know which protocol is used in my network and so on. Are you okay? So let me write it. Fragmentation is never done at sender side. Fragmentation is never done at sender side, because sender already know the DLL protocol at data. Okay, or DLL protocol payload size. It already know which DLL protocol I am using and what is the payload size there. It already know. Okay, so segmentation is done in such a way. Segmentation is done in such a way that fragmentation is not needed. Fragmentation is not needed. Okay, so now question arises, who will do this fragmentation? So if sender is not doing, then why we are studying it? So I will answer it. Don't, yeah. So obviously in intermediate router we have to do. Okay, so we will study that, don't worry. But basic thing is, let me show you how beautifully we will do it. Take the snapshot. I will jump to the next slide. Okay, so now I will start from bottom to top. Data link layer. Data link layer, I am saying Ethernet is used. So they will ask this question. By the way, this is numerical in gate. Ethernet is used. So they will say header, trailer, and maximum data is 1500 bytes. This 1500 bytes will be the size of datagram. Are you getting it? This is the size of datagram. So that means a minimum header in datagram is 20. So you will say 1480 byte data allowed in datagram. So now you will say this 1480 is the size of segment. So 20 header. So you will say 1460. So maximum data inside segment, if Ethernet is used, that is 1460. Maximum data inside datagram, if Ethernet is used, that is 1480. Okay. So maximum data inside segment. They have asked these questions. Inside segment, if Ethernet is used, You will say 1460. Let me copy it. Maximum data inside datagram. If Ethernet is used, 1480. They will say maximum. Now they can make any question. Maximum size of segment. Maximum size of segment 1480. Maximum size of datagram 1500. You will add them, no? Okay. So maximum size of segments. Size of segment means header and data both. Okay. So maximum data, they can say payload also. Payload inside segment. Maximum payload, that will be 1460 and so on. Okay. So segment size, maximum segment size, or MSS. MSS is maximum segment size. We will use this terminology, don't worry. In TCP, maximum segment size, MSS, that should be 1480. Okay. Maximum datagram size, 1500. Okay, that's it. So I think you have got the point. So now there is no question of doing fragmentation at sender side, because segmentation is done very beautifully. So why you need to do fragmentation at sender side? Yeah. So now question arises. Let me jump to the next slide. Take the snapshot.
Done, sir.
So now question arises, who will do fragmentation? Who will do this fragmentation? So see this, imagine this is a network. Okay, so computer A is there, and it wants to send message to some other computer B, which is in some other network. Okay, so now, okay, and in between that there are many routers and all. Or let me join it by one router only, just to save the time. Okay, otherwise it is wastage of time. Okay, so now A knows my MTU is, say for example, MTU is say 520. MTU means maximum transmittable unit. Maximum transfer unit. And that is nothing but datagram size. That is data in frame. Datagram size means what? Data in frame only. Frame data is datagram, na? So datagram size means header plus data. Do not get confused here. Header plus data. Okay. So maximum transfer unit is data inside frame. That is nothing but your datagram size. So MTU is 520 here. So obviously A will not do fragmentation. A will do segmentation in such a way that fragmentation is avoided. Okay. So finally it will transfer data to this router. Now problem is that, for example, here MTU is say 200. So now this router has to do fragmentation. That means it will divide the datagram into small parts so that it can be transferred to this network. Otherwise this network will not be able to handle this 520 bytes data and so on. Okay, so this who will do fragmentation? Intermediate router will do fragmentation. And why they want to do? Because they have received a big datagram, but in the network which they want to send packet, that does not support that much amount of datagram size and so on. Okay, so I think you have got the point. This figure is self-explanatory.
Yes, sir.
Okay, yeah. So now take the snapshot. I will jump to the next slide, and now we will start this topic slowly. Okay. So first of all, you should know the very basic point in fragmentation. Now I'm going to start this fragmentation. Basic over. First basic point is header and data. This is total your datagram. So fragmentation is done only for data, it is not for header. So that means you will divide this data into say 3 parts. Okay, so what you will do? So you will take this first part, this is the second part, this is the third part, and this header will be copy pasted. Of course it will not be copy pasted as it is. We will change few fields and all, and we will get the answer. Okay, so header is copy pasted. We will say it is data 1, it is data 2, it is data 3. So the basic point here is data inside datagram is fragmented, header is never fragmented.
Yes, sir.
So please write it. In fragmentation, data inside datagram is fragmented. That is, header is never fragmented.
Yes, sir.
Data inside datagram is fragmented. That is, header is never fragmented. Is it okay?
Yes, sir.
We will make some parts of it and we will apply a header as it is. Okay, of course we will change few lines, and one beautiful numerical has been asked. See this, many students have done this question wrong. Let me jump to the next slide. If you know this concept, then you will be able to answer it. Take the snapshot. I will jump to the next slide.
Yes, sir.
Okay, so now question is datagram size they are given, or they will say length of datagram. Length of datagram is 1000 bytes. So what do you mean by this? Header plus data.
Yes,
Okay.
sir.
Length of datagram size, that is header plus data. You should know these things in your mind, back of the mind. Okay, and we need to make fragments of 100 bytes. We need to make fragments of 100 bytes. Okay, how many fragments? How many fragments? Assume many of you by common sense will say datagram size is 1000 and we need fragments of 100 bytes, so it will be 10 answer by common sense, but it is not that much easy. Okay, length of by common sense you will say length of datagram is 1000 and we want to make fragment of 100 bytes each. So how many fragments? 1000 by 100, it is 10. But no, see this concept which I have told you. Header and data will be fragmented, header will be copy pasted. So now total length of datagram is 1000 bytes. So what do you mean by 1000? 20 and 980. This 980 will be divided, and each segment size is what they are saying. Each fragment size is saying 100 bytes. So 20 will be taken by a header, na? So only 80 will be left. So answer should be 980 by 80. Okay, so 980 you will divide into 80. So what will be the answer? 12 point something. So obviously 13 is the answer.
Yes, sir.
Okay, so 10 is not the answer. First option will be 10 only, and many students will take 10 but because just by common sense, 1000 by 100 that is 10 only. But no, answer is 13. Why 13? I think you have got the point.
Understood, sir.
Yeah, so take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now I will try to explain the fields, these fields one by one. What were the fields? ID, fragmentation of flags, and fragmentation offset. ID, flag, and fragmentation offset. I will first explain these fields and then we will solve a simple numerical which will explain all the points about fragmentation. First I have to explain these fields. Try to see this. In the datagram we have left these three fields now.
Sir. Identification, flag, and fragmentation.
Identification, flag, and fragmentation offset. So let me start that. Okay, so first field is identification field. See, every datagram in internet is unique. So how you will guarantee this uniqueness? Every datagram in internet is unique. Each and every datagram which is traveling, this uniqueness will be guaranteed by SIP and DIP because they will be unique. Okay, but what if same sender is sending multiple datagram to the receiver, same receiver? So then SIP and DIP will be repeated. So how you will guarantee uniqueness? Uniqueness will be guaranteed by this ID field or identification field. Okay, so see, this is the sender, or this is a simple computer. Okay, so whatever datagram it is sending, so it will maintain a counter. Okay, this counter will start with a random value, counter with some random number. Okay, whenever computer is booted, it will start with a random number and it will keep on incrementing one by one the moment it sends a datagram. Okay, like for example, random numbers was 1 2 3 4. So first packet 1 2 3 5, next 1 2 3 6, next 1 2 3 7, dot like this. So it will keep on incrementing the moment it send a datagram. Any doubt?
No.
So this is identification field. So first will be 1 2 3 5, next will be 1 2 3 6, then 1 2 3 7, and so on dot dot dot. Okay, so I'm just giving you rough idea. I'm not going into detail. I'm just giving you a rough idea. This might be done for identification. Okay, so now every datagram will have different ID. Okay, but if we have done fragmentation of the datagram, then this ID will be same. So now I think you have got the point that if we have done fragmentation of datagram, then how receiver will be able to identify that these are fragments of the same datagram. They are not different datagrams. So a receiver will come to know about the ID field. If ID field is same, that means datagram is fragmented. Okay.
Yes, sir.
Okay. So you can write down this point. Whenever datagram is fragmented, then whenever datagram is fragmented, then this identification field will be same for all the fragments. Then this identification field will be same. This identification field will be same for all the fragments. Will be same for all the fragments. Okay. So directly and indirectly I want to say whenever two or more datagram has same ID, that means they are fragmented. Okay. So whenever two or more datagrams have same identification, then this means they are fragmented datagrams of a single datagram. So we should write this point. Two or more datagrams have same ID. This means they are fragments of same datagram. Okay. Yes. So you can take the snapshot. I will jump to the next slide. Yes, done. Okay. So this is all about identification. Next is flag. Flag, I have told you this is 3-bit field. Okay. So these are the 3 bits. So this is reserved for future. Here we have D and here we have M. D means do not fragment. Flag means I think you already know 1 bit. Okay, 1 bit flag, always 1 bit flag. You will study that in architecture also, computer architecture. So D means do not fragment. M means more fragment. D means do not fragment. M means more fragment. Okay. So do not, obviously when it is a flag, it is of 1 bit. So what are the possible values? Let me write it. D and M. 0 0 0 1 1 0 1 1. Okay. So now I think more fragment value can be either 0 or 1. I think you have got it. Do not fragment field can be either 0 or 1. So that's why we have got 0 0 0 1 1 0 1 1. Any doubt here? Okay. So now if more fragment value is 0, that means what? No more fragments are coming. Okay. So that means it is the last fragment. So last fragment, I will solve a numerical. First I am explaining you these field values and then I will solve a numerical. So numerical you will come to know when more fragment field value is 0, directly and indirectly it means the last fragment. It is the last fragment. Or you can say last part of the datagram. More value 1 means more fragments are coming, that is it is not the last. It is not last. That is more are coming. More are coming. So you might be able to guess it now. 1 means true, 0 means false. More fragment 1 means it is true, that means more are coming. More fragment 0 means false, that means no more are not coming, that means it is last fragment. Like this you can remember. Do not fragment. Do not fragment 0 means it is false, that means you can do fragmentation. Do not fragment 1 means you cannot do fragmentation. Okay, we can't do fragmentation. Okay, so can't do. And this means we can do. Okay, so it is not guaranteed that you have done fragmentation. It is like that you are saying we can do it. We have done or not done, that is a different story. This means we can do fragmentation. One means you cannot do. So if you want to do see this, if router has received a packet, okay, and do not fragment field is set to 1, or do not fragment field, d flag is 1, and it wants to do fragmentation, because for example size of datagram it has received is 520, but in other network which it want to transfer is 200, so it has to do fragmentation, because this network will not be able to identify this 520 byte data, but d flag is 1. So what it has to do, only option is router will drop the packet, and if router drop the packet, it will send what, ICMP error message to the sender regarding that your packet has been dropped because of such and such reason, and so on. So just remember this thing, whenever packet is dropped, whatever may be the reason, you have to send ICMP error message to the sender regarding your packet has been dropped. Okay, so this is another reason of packet drop. So slowly I am telling you all the reasons of packet drop, and once we will complete this, then obviously next protocol we are going to start is ICMP, and you will get more clarity when we will study these messages in ICMP. Okay, so that's it. So if do not fragment field is 1, then you cannot do fragmentation, and if you still want to do fragmentation, then router will drop the packet and send ICMP error message to the sender. Okay, but it is sure that it will not do fragmentation. Okay, yeah. So now we will try to answer this question. If do not fragment field is 0 and m is 0, what is the conclusion? Now you have to see carefully, or let me do it in the next slide, because it is like little bit confusing part, so it will create problem. Take snapshot of this. Done? Okay, yes. So now I will say d and m value 0 0 0 1 1 0 1 1. What do you mean by 0 0? Do not fragment 0 means we can do fragmentation. I have told you we can do. It is not guaranteed that we have done it. We can do it. More fragment 0 means it is the last fragment. So I will say if fragmentation is done, if fragmentation is done, then it is last fragment. Any doubt here?
No, sir.
Okay, so but it is not guaranteed that you have done it. That is for sure, because D0 means I have told you in the previous slide we can do fragmentation. It is not guaranteed that we have done it. Okay, so that's why I have written like this. If fragmentation is done, if it is done, then it is the last fragment. But if it is not done, then no problem. Okay, next 0 1. What does this mean? M value 1 means more fragments are coming. So this means this is guaranteed that fragmentation has been done and it is not the last fragment. Any doubt here?
No, sir.
So what is the conclusion? This conclusion I have been asking it. That's why I am spending a lot of time here. Fragmentation is done and it is not the last fragment. But here it was not guaranteed. If I say fragmentation is done, you will say no, I do not know this thing. That's why I've written if fragmentation is done and it is last fragment. Here, what is this? D value 1 means we cannot do fragmentation. And M value 0 means it is the last fragment. So it is just like that. Only one child is there in the class. You will say it is first, it is last also. Okay, so like that only. So you will say fragmentation is not done. Okay, and obviously it is the last fragment. Last fragment means yes. If if fragmentation is not done, then this is the first fragment also, this is the last fragment also, because there is only one child in the class. That is first also and last also. So no need to worry. I will but final conclusion, that was just for understanding. Final conclusion is fragmentation is not done. That's it. Fragmentation not done. Okay?
Yes, sir.
What about this? This is saying fragmentation cannot be done and it is saying more fragments are coming. Isn't it contradictory? Not allowed.
It is.
So it is not allowed. Double one not allowed. This question I have been asking it. D and M value. Which combination is not allowed? Double one is not allowed. Very simple. Okay. Yeah. So we have now done about flags also. Last field which is left is fragmentation offset. So let me done that also. Take the snapshot.
Done, sir.
So fragmentation offset. What is this fragmentation offset? For example, I am saying we have 2000 byte data. 2000 byte data in datagram. In datagram. Okay, and we want to make fragments. Say I want to make 3 fragments. And they will directly ask you fragmentation offset. So I am assuming, okay, I am assuming that how we have done it. Let me tell you that thing. First fragment is of 800 byte. Next fragment is of 800 byte. Next fragment is of 400 byte. They will clearly mention. They want fragmentation offset. 2000 byte data in datagram is fragmented in 3 fragments, and these 3 fragment size is this. So what is fragmentation offset of each fragment? Are you getting it? Okay, so first of all you should remember that we will start with byte number 0. So I will say 800 means 0 to what value? 799. Okay, because 0 to 799 counting is 800. Now what is the fragmentation offset? Fragmentation offset is first byte number divided by 8. 0 divided by 8, that is 0 is the answer. Next, from where you will start? 800. 800 to 1599. Any doubt?
No, sir.
So what will be the fragmentation offset? 800 by 8, that is 100. 100 is the answer. 0 is the answer. Next, from where you will start? 1600 to 1999. So 1600 divided by 8. What is the answer? 200. Now you might argue with me, we are dividing by 8. What if first byte number is not divisible by 8? Not allowed. Simply say not allowed. So directly and indirectly I want to say you want to make 3 fragments. What if you want to make first fragment of 900, second fragment of say 705, and so not allowed. Okay, this is not allowed. So first condition should be that in fragmentation first byte number should be divisible by 8. That is for sure. Okay. So directly and indirectly I want to say that size of each fragment, directly and indirectly you have got it. Now size of each fragment should be multiple of 8. That is for sure.
Yes, sir.
But except the last. Last might not be multiple of 8. For example, in place of 2000 I want to send 1900 bytes then. Okay, so then obviously this last fragment will be of 300. Now 800, 800, 300. 300 is not multiple of 8.
Yes, sir.
Okay, so that is the basic thing. So size of each fragment should be multiple of 8 except the last fragment. Please write it. Size of each fragment should be multiple of 8.
Yes, sir.
Size of each fragment should be multiple of 8 except the last fragment. Except the last fragment. Because fragmentation offset is first byte number divided by 8. Because fragmentation offset is first byte number divided by 8. That's why. Is it okay?
Yes, sir.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
Now they will say sender wants to send 5000 byte data. 5000 byte data, and fragmentation is done in such a way. I'm not writing entire question just to save the time. Fragmentation in such a way that all fragments are of equal size. That all fragments are of equal size. Okay, and they want to say fragmentation offset of third fragment. How you will answer it? Very easy. 5000 byte data sender want to send. Fragmentation is done in such a way that all fragments are of equal size. Equal size means what? What will be the size? 5000 divided by 5, that is 1000. Now please check. First you have, this is the duty, you have to check 1000 is multiple of 8 or not. Yes.
It is,
So
sir.
then it's okay. Then it's okay. Otherwise we cannot do. Okay. Yeah. So it's okay.
Not 5.
1000
What
is.
we are thinking is just randomly we just thought of dividing it into 5.
No, fragmentation is done in such a way that all are of okay. Sorry for that. I have missed this point. 5000 byte data and 5 fragments. Okay, and we want 5 fragments. We want 5 fragments, and fragmentation is done in such a way that all are of equal size. Fragmentation offset of third fragment we want to find. Okay, so we want 5 fragments. Yes. So what is fragmentation offset of third segment? Third fragment. Sorry, third fragment. Yes. So I think it's very easy. So 0 to 999 in first, second 1000 to 1999, in third 2000 to 2999, and they are saying for third fragment. So 2000 divided by 8, get the answer.
Yes, sir.
250 is the answer. So simple.
Yes, sir.
Okay, so just for the sake of completion, here it will be 0, here it will be 125, next 250, and next I think 375, and so on, plus 125 you will keep on doing.
Yes.
Okay, so take the snapshot. I will jump to the next slide.
Done, sir.
So we will solve few more questions, and then we will solve a beautiful numerical. Okay, a packet arrives with mbit value 0. Packet arrived at router with mbit value as 0. Is it first, middle, or last fragment?
First one, sir.
Can we say about fragmentation done or not? How you will answer it? Packet arrive at router with mbit value 0. Is it first, middle, or last fragment? Can we say about fragmentation is done or not? Mbit value 0 means I will simply say no other fragments are coming. That means it is the last fragment. But this is the case if fragmentation is done. If fragmentation is not done, then also it will be 0, na? Because first and last one are the same thing. So first of all, I cannot guarantee fragmentation is done or not. Can we say about fragmentation done or not? No, I cannot say. No, I can't say. I cannot say this thing. Fragmentation is done or not. But if it is done, then this is for sure it is the last fragment. Any doubt?
No, sir. If not done also, it is a last fragment, sir.
Same thing. Now, if fragmentation is not done, then we have only one datagram, or we will consider it as only one fragment. So if we have one fragment, it is first also, it is last also, everything it is the same. One student in class, he is first also, he is last also.
Yes, sir.
Okay, one student, just consider this as one.
Yes, sir. Yes, sir.
So take the snapshot. I will jump to the next slide.
Done, sir.
So I will copy this slide because I want to do some changes here. Duplicate. So if packet arrive at router with mbit value as 1, what can you say about all the things? Can we say fragmentation is done or not? 100% we will say it is done, because more fragments are coming. Now can you say about it is first, middle or last? This is for sure it is not last. I cannot comment about is it's first or middle. Any doubt?
Yes, yes, sir.
So it is not last. I will say it is not last. That is first or middle. But what exactly it is, I do not know. Okay. So now question arises, how you will check is it's first or middle? So for that we will use fragmentation offset value. If fragmentation offset value is 0, then it is for sure it is the first fragment.
Yes, sir.
Any doubt? See the numericals we have already done. Fragmentation offset was 0. That means it is the first fragment because we are starting with 0. 0 by 8, that is 0. Any doubt? In the previous also we have studied 0 to 799. So 0 was the answer. So how you will check? To check it is the first fragment, you have to check fragmentation offset value. It should be 0. Okay. Yes. So now question arises, how to check it is first or middle? How to check it is first or middle? I will say check fragmentation offset value. Check FO value. FO value 0 means it is first. If it is not equal to 0 means it is middle. Okay, and it is roughly middle. It is, you should not say it is exactly middle. Like 5 fragments are there, then it is the third fragment. We are not saying exactly middle. I am saying it is not first, it is not last. That means it is middle. Any doubt here?
No, sir.
Okay. Yes. So now I think you have got the point. Check fragmentation offset value. If fragmentation offset value is 0, then it is the first fragment. If it is not equal to 0, it is the middle fragment. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. Now I will directly say fragmentation offset value is 0, mbit value is 1. What is this? You will simply say it is the first fragment. That is fragmentation is done.
Yes, sir.
Fragmentation done 100%. Yes. Take the snapshot. I will jump to the next slide.
Done, sir.
Another beautiful question is coming to my mind. Fragmentation offset is 0. Mbit value is also 0. What do you mean by this?
It is the first and the last.
First and the last means?
Fragmentation is done.
It is first also and it is last also.
Yeah.
That means only one student in class, you are saying it is first as well as it is last.
Yes.
So the fragmentation is not done.
Yes, sir. Yes, sir.
Fragmentation not done because it is saying it is first, it is saying it is last. So first and last same. First and last same means only one fragment. Only one fragment means fragmentation not done. Okay.
Yes, sir.
Okay. Next question. Fragmentation offset value is 100. What is the first byte number? First byte number in fragment. Reverse question, just reverse. First of all, please tell me how you have calculated this 100.
0 to 99, sir.
No. Fragmentation offset value is 100. This means what? How you have calculated this 100? You will say first byte number in the fragment should be 800. Now 800 to something, I do not know till where. But this is for sure that first byte number was 800.
So divided
then
by 8.
What you have done, 800 divided by 8 and you have got the value 100.
Right, sir.
So now they are saying first byte number in the fragment. Obviously, we will say what this is the 800 answer. So simple. So multiply by 8 and get the answer. See this, very simple. Now first byte number
Sir, understood, sir.
divided by 8, that is fragmentation offset. Now they are saying for first byte number, so fragmentation offset multiply by 8 and get the answer. Multiply by 8 and get the answer 800. So simple. Okay.
Sir.
So now, can you comment about last byte? Last byte number in fragment?
No, sir, because that is not the. Um, we may not
No.
have the.
Till what point we are going, we do not know. Last
Uh,
byte number in fragment, I cannot comment. So to find the last byte number, what I need? Let me give you small hint. If I give you total length field, will you able to answer it?
yes, sir.
Let me give you that. Take the snapshot. I will jump to the next slide.
That's it.
Okay. So now question is, fragmentation offset value is 100. Total length field is also 100. Okay, these are in decimal values. Okay, fragmentation offset value 100 in base 10, total length field is 100, that is also in base 10. I am specifying it because they can give you hex also, hexadecimal also. Okay, so for hexadecimal you have to convert it into decimal and then you will be able to answer that question. So that will be difficult kind of thing, and rather not difficult, calculation will be very high, and I am assuming that you can do those questions. So I am just, for the sake of simplicity, I am using decimal. Is it okay?
Yes, sir. Yes, sir.
Okay. So if they give hexadecimal, you can convert into decimal and get the answer. Okay. So fragmentation offset value is 100. Total length field is also 100. Now tell me the last byte number. According to you, what should be the answer?
900.
900. Okay. Yeah. So you have done a good try. 800 starting. Then total length is 100. So 800 plus 100 you will say. 900. Little bit calculation mistake. According to you also. It should be 899. Na?
Yes, yes, sir. Mm.
Please avoid these
When we
things. So
say,
first is 800.
uh,
Hmm. Okay.
yes,
Now,
sir.
but actually it is not the answer. Why?
Mm.
Why? Because total length field I have given. I header is of variable length, na. I
Mm.
have not specified the header length. How you will calculate the data?
Yes, sir.
And you have considered header also in that. See, if I go by your concept, then 899 should not be the answer. 100 is the total length. Total length means header plus data. So you have included header in that also. How you have
Yes, sir.
included header in that? Because fragmentation is for data only. It is not for header. Okay. So last byte number is for data. It is not, you will not consider a header in it.
Mm.
So, and since we have not given you the header length, you cannot answer this question. First of all, you should know this fact. Fragmentation offset is given, total length field is given, header length field is not given, so you cannot answer it. They can twist the question and they will say maximum fragment length, or you can say maximum size, or they will simply specify minimum header you take. Like this, they will give you small hint in the exam, then you will be able to answer that. Okay, but you have to specify header length properly, or directly or indirectly you have to specify header length. They will say minimum header, assuming minimum header. So if you assume minimum header, then minimum header
20.
is
20.
first of all I will cross it, and then I
Mm.
will modify the question and I will write. Okay, I will do it in the next slide. Take the snapshot.
Done, sir.
So I will say fragmentation offset is 100 and total length field is 100. Okay, and minimum header, or they will say maximum data is there. One and the same thing, na. Maximum data, that means header is minimum.
Yes, sir.
So you will say minimum header is 20 bytes.
20.
So data is 100 minus 20, that is 80 bytes.
Mm.
So
8.
fragmentation offset is 100. So you will start from 800 and then you will add 80.
8.
Minus 1 you have to do because 800 is included. 879 is the answer.
Yes, sir.
Okay.
Yes, sir. Mm.
So simply saying, they can give, if they want to ask simple question, they will say fragmentation offset is 100, total length field is 100, and header length field is 5. So what is the answer? So fragmentation offset is 100. So you will say 8 into 100, that is 800, plus total length field is 100, header length field is 5. So 5 into 4, 20. 100 minus 20, you will get here 80, and then minus 1. Again, you will get 879 as the answer.
So,
Hmm.
because it was less than the minimum header length, we have to enhance it. 5 into 4, 20.
value is 5.
Huh.
So header length was multiplied by 4 to get the actual
So
header length.
in case when they mention minimum header length, we need not to
Hmm.
multiply by 4.
If they say minimum header, see actually I think I have got the point. Your confusion is it is actual header length or it is header length field value. So if they will say header length field value.
Okay, sir.
So header length field value is 5. Now you will say 5 into 4, that is 20.
Huh.
Okay, or otherwise they will answer I have used the word HLEN. HLEN is the field value, na? See
Okay,
this.
sir.
In header we
Sir.
have used HLEN. If they say
Done.
HLEN, you will say it is field. Or otherwise they will say, they will simply write in English proper header length. Header length is. If they say header length is, then you will say normal. Do not multiply by 4. If they say header length field, then multiply by 4.
Right, sir.
Okay. So let me write it because many students might get confused here. So header length. Simply you will specify, no need to multiply. No multiplication needed. If they say header length field, yes, multiplication is needed. Okay.
Yes, sir.
Yeah. So now our basic concepts is over. So now I will try to solve a simple numerical. Now you will be able to guess it very, very easily. Take the snapshot. I will jump to the next slide.
Done, sir.
Router has received datagram of size 520 bytes, but MTU of destination network is 200 bytes. Show the fragmentation process. Bas. That's it. Fragmentation show. Okay, I'm not writing question. I will simply show. I have just shown you the situation. Router has received a packet of 520 bytes, but it has to transfer it in a network where MTU is 200. So what do you mean by MTU? Maximum data in the frame. Maximum data in the frame is size of datagram. That is size of datagram is 200. Size of datagram 200 means maximum data in datagram can be 180. Any doubt here?
No.
Okay, then. So now we will start. So 520 byte datagram it has received. So if nothing is specified, you will take minimum header. Minimum header is 20 byte. So that's why I've taken this figure so that we do not get confused. So 520 byte means 500 is the data, round figure. Okay. 520 byte datagram means header plus data. So data will be of 500 byte. Yeah. So I will okay. Let me jump to the next slide. In fresh slide, I will do the things. Take the snapshot.
Done, sir.
So I will say $20 bytes and this 500 byte. Okay, and maximum MTU was 200, na? So 200 means maximum data what you can keep is 180.
180.
Any problem?
No.
So next 20 and 180. 360, na?
Yes.
Next 20 and 140.
Yes, sir.
Okay. Now question is, can we do like this or not? By common sense we have done it. Can we do like this? You should check. 180 is multiple of 8 or not? No. So we cannot do it. So now what is the scenario? So you just check smaller number less than 180, or you can say less than 180 number you should check.
160?
Okay. No. Just less than 180. 176.
Which is divisible by 8. Yes, sir.
Which is divisible by 8. That is 176. So you will
Yes,
take
sir.
176. Okay. So I will take fresh slide. Take the snapshot.
Done, sir.
Okay. So now I will say 200, 20, 500. So first will be 20, 176. Then again 20, 176. And then last will be 176 plus 176. What is the value?
252, sir.
52. 252 minus 500?
248, sir.
No. 148.
148, sir.
So last fragment will be, now it hardly matters. 148 is divisible by 8 or not. It hardly matters to me. This should be divisible so that I can find the fragmentation offset. Okay. So now what are the three fields related to fragmentation? Identification, flag, and fragmentation offset. So I will try to find all the values here.
So
Okay.
it is
So now,
sorry for the wrong addition. 356.
it was 356. This
Yes,
one.
yes. Yes, sir. Yes, sir.
How? 176 plus 176, 6 plus 6, 12.
Yeah, 356, sir. 356.
No. 6 plus 6 was there, na?
Sir.
So 6 plus 6 is 12. So 2 and 1, 7, 7, 7, 41, 15. 352. 352. Okay.
Sorry, sir. 352, sir. 300 I was just focusing.
352. So it will be now it's take. Okay. So 176, 176 and 148. Okay. Now I want to say this is most of the work is over now. Now I want to find the value of all the fields related to fragmentation. What was that? Identification. Flag was D and M, and fragmentation offset. Okay, identification, flag, and fragmentation offset. There were three fields related to fragmentation. So I will find all the values. So let us suppose, so ID I cannot find, obviously I have to give the ID here. So let us suppose ID is say 1000. So I will first of all I will simply say copy paste. ID is 1000, ID is 1000, ID is 1000. Any doubt here?
No.
Because ID will be copy pasted, I have told you.
Yes,
now
sir.
what about D and M? Do not fragment, obviously do not, since we have done fragmentation, so do not fragment should be 0. If it is was 1, then how we have done it? Now tell me about more fragments. Is it the last fragment? No. So I will say more fragment is 1. Is it the last fragment? No. 1. It is the last fragment? Yes.
Yes.
So it will be 0.
0.
Now tell me about fragmentation offset value. So it will, I have to start with byte number 0, na? So 176 size, so 0 to 175. So 0 by 8, that is 0. Okay.
Yes,
Next, 176 to 351.
351, yes, sir.
176 by 8. What will be the answer? 8 to the 16, 8 to the 60, 22.
Yes, sir.
Okay. And next will be from 352 to 499. So what will be the next value? 44. How I have done it? Because 0, then 22, then 44, obviously. 22, 22, it will increase. I have not calculated 352 by 8. I have just done it by common sense. Any doubt here?
No, sir.
Okay. Yes, so that's it. We have done the fragmentation. They will ask these questions. So 520 byte is MTU. They will simply ask router received datagram of size 520 byte, but MTU of destination network is 200 byte. What is the fragmentation offset of the second fragment? What is the fragmentation offset of the third fragment? They will ask this question. What is the value of D flag? What is the value of M flag? What is the value of identification? They will ask these questions. So I hope it is clear. Now assume this fragment, second fragment, through some network, but their MTU was again, less. Okay, so I have divided it into 2 more fragments. So now I want to find the values here. Okay. So once I want to say this thing. that we have done three fragments we have done for this datagram. They will travel through different path, but this fragment, this was of 196 bytes, na? Now 196 byte come into the picture, or it goes to some network where we have to do fragmentation of this also. So the basic concept is their MT was also less. That's why we have done fragmentation. So I want to say here is we can do fragmentation of fragment also. No need to worry. Okay. So the question is, can we do fragmentation of fragment? Answer is yes. No need to worry. Yes, we can do it. So now I want to show you that how we are going to do it. Okay. Yes. So now I will say, let us suppose MTU in the network in which we want to transfer is 110. MTU is 110. Okay. So I want to say MTU is 110, from which this fragment is going. So obviously I have to do fragmentation. So how I will do it? So 110 is divisible by 8 or not? No. So what is the smallest, largest number lesser than 110 divisible by 8? 108. 108 is divisible, na? So 108 we have to do. So I will do fragmentation of this. So 108, obviously 108 is the total. So 20 byte header. So 88 is left. Any doubt? No, so here how much will be left out? 88 plus 88 is 176, na? So again 88. Okay. Yes. So now I will try to find all the values here. Identification DMFO. Identification obviously same. 1000, 1000. Do not fragment field obviously 00. Now it is important. M. Please let me know by common sense what should be the M. This is 1 for sure. What about this?
One because we have got the further packet.
Very good, very good. Yes, yes. This is left out. We have to consider this. This is the parent. This has been done fragmentation. Do not consider this as parent. So M value will be 1. Do not say it is 0. Okay. Yes. What about fragmentation offset? What is the first byte number carried here?
That is like 88 we consider now without starting from 0.
No. See this. We have done fragmentation of this. So what was the byte number in this? First of all, tell me this thing. What was the byte number in this? 176 to 351. We have to consider this as the parent, na?
176.
So what is the first byte number here? 176. So 176 divided by 8. It comes out to be 22.
Yes, sir.
Same, no problem. Same. What about this? 176 plus 88. 176 plus 88. 264. So what you will do? 264 divided by 8. Any doubt here?
No, sir.
I have just skipped one step. I should say 176 plus 88 minus 1. That is 263. 263 will be the last byte number here. So first byte number here will be 264. That's why I have just skipped one step. Minus 1 plus 1. So finally I will get 264. So 264 divided by 8 you should do. What will be the answer? 8 3s are 24. 8 3s are 24. 33. 33 is the answer. Any doubt here?
No, sir.
So that's it. So here we have completed the fragmentation part. That was important. Many times question have been asked in GATE from this topic. Okay. So now what is left out? Options are left out. So let me tell you options also. Options of IP header. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay. And let me tell you one thing. See this in IP header now. I think every field is crystal clear now. Version is clear, header length is clear, service type, total length, identification, flag, fragmentation, offset we have done, time to live, protocol, header checksum, SIP, DFP, everything is clear now, nothing, no doubt. Now we are left with options and padding. Let me tell you that thing also. What are options and padding? Okay, so what are the options? So there are options are of two types in IP header: single byte and multi byte. Single byte and multiple bytes. Single byte, no operation, and next is end of option. Multiple byte is of four types: record root, strict source root, loose source root, and the last is timestamp. Okay, so these are the total options available in IP header. I will tell you one or two lines for each of them. It is not important, but MSQs are coming now. In MSQ they will ask, and see the beauty, they have just asked which of the following is not an option in IP header. So they have given these options and one other option was there, so you will take that. So very basic questions. Okay, so these are just like lollipop questions or toffee questions. If you know the name also, you will be able to answer one or two questions in GATE regarding this. Okay, actually these are rare topics. Nobody touch these topics just because they are very difficult, that's why. So I will just tell you one or two lines of each of these. Difficult in the sense of implementation, but implementation we do not know for GATE. Okay, it is not needed, we are not doing coding and all, so you just know one line, and they just want to check GATE exam, they just want to check whether at least you have some idea of these or not. So that's why they are asking very simple question: which of the following is not header in IP? Record root, strict source root, loose source root, and another was there. So take that option and get the answer. Very simple. Okay, so 119 I will tell you, don't worry. So take the snapshot, I will jump to the next slide.
That's
Okay. So first is no operation. NOP, no operation. So what do you think? As the name says, no operation, it has to do no operation. It is nothing. So why you are adding it? It will just like it will just act like a filler. Okay, filler to fill the bytes. Why we want to fill the bytes? See, I have told you header length field value minimum was this and maximum it can go to this. So that means multiply by 4 na, 5 into 4 20. Next value is this, that means 6 into 4 24. Now where are 21 22 23? Not allowed. So next is 7 into 4 28. So what about 25 26 27? So header length cannot be 25 26 27. It should either it is 24 28 20 and so on. So multiple of 4. Directly indirectly I want to say it should be multiple of 4 because header length field was multiplied by 4 to get the actual header length. It should be multiple of 4. What if we have used options in such a way that it is not coming to be multiple of 4? So you will add NOP to it so that it becomes multiple of 4. That's why I have told you it is just acting like a filler to fill the bytes so that header become multiple of 4. Any doubt here?
no, sir.
Header become multiple of 4 bytes. Okay, that's why it is just acting like a filler. Okay. Yeah, so this is all about NOP. Next is end of option. End of option, that is obvious. Options are of variable length, na? 0 to 40 bytes. So when can you say that options are over and now my data is starting? Because they are of variable length. So you have to specify end of option. That means the next whatever is coming, that is data. Okay. So next is end of option. Since option of variable length, since option are of variable length, so this field give info about end of options and starting of data. That's it. No need to dig deep. What is the value of this and so on. That is implementation part. Gate will not ask this question. Obviously, binary you cannot remember, na. If I tell you how end of option look like, what is the use? You will not be able to remember it, and Gate is not going to ask it. So why to dig deep into these topics? That's it. This is all about end of option. Now we are going to start.
And
Options are of variable length.
Of,
information about end of option and starting of data.
Yes, sir.
Okay. Yes. So now next, what was that? Record route. Record route. Let me tell you that. So record route is an option which is for diagnostic purposes. Okay. That means if see this. This is sender and there are these routers in between. So if sender has activated this record route option, then when datagram will be received by this router will put its IP address in the datagram. Then it will jump, it will go here, then this router also will put its IP address in the datagram. It will go here, then this router will also put its IP address in this datagram. And finally receiver receive it. So receiver will come to know that okay, these are the three routers in between sender and me. Okay, and it can, as the name said, record route. That means it is simply recording the route from where it is going. That's it. Okay. So it is used for network diagnostic purposes. That means if receiver has received, so directly and directly you come to know that these three routers are working perfectly fine. Since sender has sent the datagram and receiver has received it, that means these three routers are working perfectly fine. So please write it. It is used to record. It is used to record the IP address of routers that handle the datagram. It is used to record the IP address of router that handle the datagram. That handle the datagram.
Yes, sir.
Okay, and it can store up to 9 routers addresses. It can store up to 9 router addresses. Why 9? Because 4 byte IP address is there, na? IPv4. So 9 into 4, 36 bytes. 36 byte option, and we have to add no operation and something other are also there. So 36 is the upper cap. We cannot go till 40. Okay. Because end of option is necessary. If end of option is not there, then how receiver will come to know that options are ended and data is starting. Okay, we have Is, we can say this is IP 192.168.1.2 and so on. We can say this is IP, but actually binary, everything is binary. So how receiver will come to know that this binary is for IP address and this binary is for data and so on? It cannot differentiate. End of option is must. Okay, so that's how, if 40 bytes, entire 40 bytes are given to you for storing IP addresses, then where end of option will come? So that's why only 9 router addresses it can keep. Any doubt?
Yes, sir.
Okay. Time left or we are already out of time? Okay, so it's all. Okay, so we will wind up the class here itself. In the next class, we will start from here.
Done,
okay. Yeah, so and just write one more line. It is used for debugging and network management. It is used for debugging and network management. That's it. Okay. Yes. Okay. So thank you so much. Bye bye. We will start from here itself in the next class.
Thank you so much, sir.
Okay, then bye bye.